I'm Anil Kumar, and here we have a quadratic equation in two trigonometric ratios. 8 sine square x minus 10 cosine x minus 11 equals to 0. This is like a test problem for you. You can pause the video, solve, and then look into my suggestion. Now in such questions, we need to write sine square x as 1 minus cos square x so that we get one quadratic equation in one trigonometric ratio, right? So we'll do that. So 8 times 1 minus cos square x minus 10 times cos x minus 11 equals to 0. Open the bracket. 8 minus 8 cos square x minus 10 cos x minus 11 equals to 0. Now that gives us minus 8 cos square x minus 10 cos x, and 8 minus 11 is minus 3. It's good to just make them all positive, right? So we'll say multiply by minus both sides. So 8 cos square x plus 10 cos x plus 3 equals to 0. So we are looking for two terms which are product is 24 and the sum is 10. So that is 6 times 4, right? So we could write 10 as 6 and 4. So we have 8 cos square x plus 6 cos x plus 4 cos x plus 3 equals to 0. Combine these two. 2 cos x is common. So we get 4 cos x plus 3 plus we already have 4 cos x plus 3 here. 4 cos x plus 3 is common. So you get 2 cos x plus 1 equals to 0, right? Now for this quadratic equation, there are two factors, so we are looking for these two factors to be 0 to get us all the possible solutions, right? So one set is when 4 cos x plus 3 equals to 0, which is cos x equals to minus 3 over 4. The other one is 2 cos x plus 1 equals to 0. That is to say cos x equals to minus half, right? So these are the two sets which will give us all possible angles within 0 to 360 degrees for the solution, right? So let us see how to solve them. So let's begin by cos x equals to minus 3 over 4. So the idea here is first find the related acute angle. So negative cos means we are looking for solutions in quadrant 2 and 3, right? But first we need to find the related acute angle. Let us say the acute angle is beta for us. So we say cos beta equals to 3 over 4. So beta is equals to cos inverse of 3 over 4. So we'll do shift cos inverse and brackets 3 divided by 4 bracket close equals to. We get 41.4 degrees, right? So cos inverse. So we know beta is 41.4 degrees. So how much is these two angles? So x values will be 180 degrees minus 41.4, or it will be 180 degrees plus 41.4. Since it is negative, it has to be in quadrant 2 or 3. How do we get it? We get it from the cos rule, right? So that is the rule. So cos is negative in these two quadrants. So let's add 180 degrees to this. We get 221. So this is 221.4. 180 minus 41.4 will be 138.6. So these are the two x values from the first factor. Now let's analyze the second factor, which is cos x equals to minus half. You can also use special triangles. We'll apply the second strategy using special triangles. So you know special triangle 1 to square root 3. Cos of half means we're looking for this angle, which is 60 degrees, right? So we know beta, the acute angle for us, is 60 degrees. Is it okay? Now what is the angle? Because cos is negative in quadrant 3 and 4, the angle x will be equal to 180 degrees plus 60 degrees or 180 degrees minus 60 degrees, right? So when you add, you get 240 degrees. When you subtract, you get 120 degrees. So our answer here is all these four values. You could write 138.6 degrees, 221.4 degrees, 240 degrees and 120 degrees, right? So these are the four solutions for the given equation. I hope you understand and appreciate the steps. So whenever you have quadratic type of equation with trigonometric ratios, try to get the equation in one term, and that is possible by utilizing most of the time the Pythagorean identity sin square x plus cos square x equals to 1, right? And that is why we wrote sin square x as 1 minus cos square x, right? So, and then you get quadratic equation in just one variable, which is cos x. So at times you may use factoring or even quadratic formula to get the values and then find the values as we did here. I hope that helps. Thank you and all the best.